In this video, we're going to take a look at two problems where we're looking at determining the linear equation y equals mx plus b from 2 points. Now, this first problem, I'm going to give you a point on the y-axis. In the second question, I'm going to give you a point on the x-axis. We can solve it in the exact same way. We can see how they fall out, right? It can be convenient ways to solve these types of problems a little bit quicker if you want like. All right, so our first problem, we have 2 points. Our points are 1, 2, and 0, 5. Now, even though we have the y-intercept already, because it's on the y-axis, we're going to solve it the same way we did in the previous videos, just to get some practice. Because typically you wouldn't get a point on one of these axes. So remember, when we have 2 points, essentially we're trying to determine our slope first, and then our y-intercept. So just think about the definition of our slope, y2 minus y1 in the numerator and x2 minus x1 in the denominator, representing rise over run. You can look at these 2 points and already know that we should get a negative slope. So we plug in our values. We get y2, which is 5, minus y1, which is 2, and then divide that by x2, which is 0, and x1, which is 1. So 5 minus 2 is 3. Divided by -1, we get -3 for our slope. Okay, now we can use that to determine our y-intercept b by rewriting this equation and then isolating our b term. So we write this equation as b is equal to y minus mx. And again, you can choose either point 1 or point 2 to plug in to solve for y-intercept b. In our previous video, we used point 2 to determine that. This video, we're going to use point 1. It really doesn't matter. Both will give you the same answer. So if I use point 1, I'll plug in y is 2, m, my slope, is -3, which we just solved for, and x1 is 1. So I get 2 minus -3 times 1, or 2 plus 3 is equal to 5. All right, so that matches our y-intercept, and that means our linear equation is y equals m, which is -3, x plus our y-intercept 5. So -3x plus 5. Now, a lot of times, whenever you have a point that has a 0 term, that may be convenient to use, right? So if you just plug in x2 and y2 to solve for your y-intercept, then 0 for x2 would drop out this term, and then you would say CB equals 5, right? And so obviously in a real problem, you wouldn't actually solve it. You would just take that value of 5. All right, let's take a look at our second problem. See, here on our second problem, we have a point along our x-axis, 4, 0. And then we have a random point, 2, -3. So again, we're going to solve for our slope and then our y-intercept. So click pause and see if you can solve it in the similar fashion. Look at where the points are. Does it look like you have a positive or negative slope here? Right? Always a good check to make sure you understand conceptually. Sometimes you won't be able to draw a graph. All right, so rise over run, y2 minus y1, that would be 0 minus -3 divided by our run, 4 minus 2. So -3 will give us +3 over 4 minus 2, which is 2. So 3 over 2, or 1.5. Okay, now we're going to solve for the y-intercept b. Again, I can choose point 1 or point 2. It might be a little bit faster if I chose point 2, because then the y term will go to 0, but I'll let you solve that one on your own to check. I'm going to use point 1 in this case. So y1 is -3. Our slope is 1.5, and x1 is 2. So we just plug that in. We get -3 minus 1.5 times 2. 1.5 times 2 is 3. So -3 minus 3 will give us -6. We plug in our slope and our y-intercept into our linear equation, and we get 1.5x minus 6. And here we have it. You can count, right? So in both cases, the x and y axes dash points are 0.5 or half. Right, so there's a half, 1, 1.5, 2, 2.5. So you can count your slopes, right? Since these are square, right, this is also on the same scale. Half, 1, 1.5, 2, 2.5. So you count them by squares. You go rise, 1, 2, 3, run, 1, 2. So even though that's not 3 steps, that's 3 increments of 0.5. So that's really going up to, what is that, negative 1.5, and it goes across by 1, right? So you can count them. The only time that you need to be cautious of doing something like that is if your x-axis and your y-axis grid size are not the same dash marks, right? So that happens often. And in that case, you want to know exactly what values you're moving up and to the right of. And then here, we said that the y-intercept is -6. Can we see that here? You can kind of see that here. It crosses here. And then for this problem, we already checked, right? So that was the y-intercept that was already given to us. So hopefully you get to see the pattern. We'll do 2 more videos with 2 points just to give you more practice.